Welcome to solverfy.
This is chapter 27, problem number 82. We have a cycloid path, which means we have electric field and magnetic field acting on a charged particle. So this is the initial position of the particle, and the B field is actually out of the page. So this is the B field, and E field is actually up. This is the E field acting. So the trajectory of the particle looks something like this. And then it reaches y equals 0 again. And then it repeats itself periodically. Now, in part A, we are asked to discuss the motion, the trajectory itself. So the particle starts from rest, right? The initial velocity here is 0. Whenever y equals 0, rv, the speed is also 0. So the particle starts from rest. The electric field generates the electric force. Since the particle is positively charged, F sub E has to be also up. This is F sub E, right, acting on the particle. And let's say particle starts from rest. So E field causes the displacement along Y, right? Along Y. And F sub B, the force generated by the magnetic field causes the curvature. So at the top point, somewhere here, at the top, F sub E, the force exerted by the electric field is up, and F sub B is down, right? And the speed of the particle has to be maximum, because initially there is no velocity. The electric field accelerates the charge by applying this F sub E, which means the speed of the particle is maximum there. And as the particle returns, to y equals 0, so it's the way back from the top, right? Let's see what happens. The E field actually slows the particle down because it's counteracting. Slows it down. If it slows down, it means smaller velocity, right? Smaller v. Smaller v means actually the B field, the force exerted by the B field is smaller now, right? So then the particle stops when it reaches y equals 0. The particle at y equals 0 stops, right? Then it gets accelerated by the electric field again, and the same cycle goes on, right? This is part A. Now in part B, we are trying to calculate the speed of the particle at any point along that trajectory. So basically, we're going to calculate the work done, and remember, work was done by the electric force times it causes the displacement along y direction times y. So then QEY equals to the work done. That work done is in the form of kinetic energy, which is 1/2 mv squared. So from here, 1/2 mv squared equals QEY. Then if we multiply both sides by 2 over m, times 2 over m. What we have is v squared equals 2qey over m. Then v is square root of this expression. At any point, we can calculate the speed. Now, part C. We're asked to apply Newton's second law at the top. So let's go back at the top. Let's see what's happening. At the top, at the top of the trajectory, this is the direction of F sub E, and this is the direction of F sub B. How do I know that? Using the right-hand rule. The B field is out of the page, the velocity is towards right, so from the right-hand rule, F sub B has to be down and F sub E has to be up. Now, the net force at the top then equals F sub E minus F, apologize for it, F sub B. And that has to be equal to negative m times a, right? Because it's I'm using the convention positive y, negative y. So then negative mv squared over r. QE f sub e is QE, QVB is also f sub b. So negative mv squared over r. Now, it's given to us that r is 2y here. And QE minus QVB then equals negative m over 2y. I substituted for r, and v squared, which is this term here, 2qey over m. Now m's are going to cancel, 2's are canceling, y's are canceling. We have QE minus QVB equals negative QE. So if I add QE to both sides, I'm going to have 2QE and QVB. If I add that term to both sides, 2QE equals QVB. So Q's are going to cancel. For V, then what we have is 2E over B, as expected.